Lesson 5.6, what we're going to be doing is we're going to be writing equations in the standard form. Now, there's 3 different forms for equations of lines. We just had a test over one of them, which was y equals mx plus b, slope-intercept form, okay? Then yesterday we learned which one? Point-slope form, y minus y1 equals m times x minus x1. And then today we're learning the third and final one that we're going to do in Algebra 1, which is the standard form of a line. Now, standard form is probably what you are used to seeing equations written like in your book, because a lot of times they write them in standard form. Now, it's not the most common for a line, because the most common for a line, so we can graph it, is slope-intercept, y equals mx plus b. That's why we did a whole test on that formula alone. This one, okay, standard form, an example of that would be something like 2x plus 3y equals 7. This is an example of standard form, because what standard form is it tells me I have the x and y variables on one side, and then the constant on the other. Remember, the constant is just the number by itself. So it always separates it, x and y variables on one side, constant on the other by itself. The standard form of a line, the equation for that is ax plus by equals c. A, B, and C, you'll never actually see in the equation. They're numbers, okay? They're numbers that represent A, B, and C. C is our constant. A and B should be coefficients, or coefficients are numbers in front of variables, all right? So, you will have to memorize this formula. The next test that you take, the first 4 questions are writing equations. Write the point-slope form. Write the slope-intercept form, write standard form, write the slope formula, okay? So, here's a couple rules for standard form. The first rule is it can never have any fractions. There are no fractions at all allowed in an equation for standard form. And also, the a, or the number in front of x, our first term, can never be negative. We would call that term our leading coefficient. Leading means the first one in line, and coefficient is just a number in front of the variable. So the first number can never be a negative number. Now, it does not matter if b or the constant are negative, but the a, the first number in standard form, can never, ever, ever be negative. So the first example, we're going to put it into practice. We have to make the equations that they have given me we got to put them in standard form. Model them after standard form. So standard form is what? Somebody raise your hand and tell me what the formula is. Stephanie?
Ax plus by equals c.
Perfect. Ax plus by equals c. I know the x and y need to be together on one side, and the number by itself, or the constant, needs to be on the other side. So let's look. Are x and y together on one side? Yes. Are the constants by themselves on the other side?
Yes.
No, because this -4 right here needs to be moved over. Can I just simply say, okay, just place it on the other side? Negative x plus 3y equals -4. No. What do I need to do to that -4 to move it over? Add 4. So now I have -x plus 3y equals 4. Is this equation in standard form? No. Why is it not in standard form? Javen?
Because the first letter can never be negative.
Okay, the first number can never be negative. So I can't just say, okay, well, let's just make that a positive one, because it doesn't work like that. I have to actually do something to the -1 to make it a positive one. Now, here's the deal about standard form. I do not want to change this actual number if I don't have to. I want to keep it a 1. I just want to change it to a positive. So there's 2 different things that I can do. And I always want you to multiply by -1. You can technically say, oh, let's divide by -1 because it's going to do the same thing. It'll change the sign. But when I teach you something a little bit in one of the other examples, it's easier just to always use multiplication. And I'll show you why. But anyways, for right now, we're going to say, okay, if I multiply this by -1, what's -1 times -1? Positive 1x. So there my signs changed. But whatever you do to one part of the equation, you have to do to every term in the equation. So that means I need to multiply 3y by -1. Multiply 4 by -1. And does everybody realize the only time you really want to multiply by -1 is just to have the opposite sign? So that means if 3y is positive, what is 3y going to change to? -3y. If 4 is positive, what is 4 going to change to? -4. So see how it didn't change any of our numbers? It just changed their signs. So now is this in standard form? Yes, because the A is a positive number. B and C are still negative though. Is it okay if those are negative? Yes. It does not matter if B and C are negative. That does not matter. All it matters is that A is a positive number and there is absolutely no fractions at all. So this is our equation in standard form. Okay? So the second example, we're going to go a step farther. First of all, I've got to put all the terms in the correct order. I need the x and y to be together on one side and our constant to be together, or to be by itself on the other side. So what do I need to move? Javen?
The -2/5 x, but it's a fraction.
Okay, -2/5 x needs to go to the other side. Now, we're trying to move terms, the entire term. So anytime we ever try to move terms, we're only ever going to use addition and subtraction. We would never use like multiply by the reciprocal, because that's when I'm trying to solve for a specific variable, like x equals whatever. I'm trying to move the whole term. So since it's in -2/5 x, what am I going to do to move it? Add 2/5 x. So it cancels out here. I add it over here. And now I have 2/5 x plus, what's the number in front of y? 1y equals -3. What's the problem in this equation? Stephanie? We can't have a fraction. So how do you think we're going to get rid of the fraction? Does anybody know, Jacob?
Wait. Well, you can't change decimal, right? You can't change to a decimal.
No, that's a great point. Hold on one second. Take a time out for a second because I want to address what he said. He said, we can't change it to a decimal, right? That is correct. Standard form, I didn't write it on this part, but standard form, you cannot have any decimals or fractions because decimals and fractions are the same thing. Basically, for standard form, you need all whole numbers. Decimals are not whole numbers, okay? Fractions are not whole numbers. So that's what we need to do. So Jacob, tell me what you think we would do. Not multiply 2/5. Nope. Okay, here, I'm going to tell you what we do. I'm going to tell you what we do. We do not divide. You multiply by the number that is in the denominator. So if I multiply 2/5 times 5, watch what happens. The 5's cancel out, and what am I left with as my answer? 2x. Does everybody see that? So, anytime you have a fraction, you always multiply by the same number that's in the denominator, and your answer will always be the number that's in the numerator. See how our answer was 2x? Because that was the number in the top. Now, whatever we do to one term, we have to do to every single term. So I've got to multiply 1y by 5, -3 by 5. So my equation changes to 2x plus 5y equals -15. Now, is this equation in standard form? Yes, it is. The x and y's are together. The constant's by itself. I have no negative first term, and I've got no fraction. So I know this is in standard form. So the next problem in this example, we're going to go a step farther. We've changed negative to a positive in the first part of the example. We've changed a fraction to a whole number in the second part. Now we're going to combine those. So first of all, before I do anything, I need to get the x and the y's on the same side. Now, there's two different ways we can do this. We can add 5x to both sides and move it over here and then just rewrite it so it says 5x plus 1/2 y equals 11. But for the sake of this example, because I want to show you something, we're going to say, okay, let's leave the negative 5x where it is, and we're going to move the 1/2 y over here. That means I need to move the 11 to the other side, okay? So first off, I'm going to move the 11. And what do I need to do to move the 11 to the other side? Subtract 11. So I have negative 5x equals 1/2 y minus 11. So now what do I need to do to move 1/2 y? Subtract it. Very good. Because it's a positive 1/2. So we subtract 1/2 y. And I rewrite it. So my equation is negative 5x minus 1/2 y equals negative 11. Now I've got two problems. First problem is my leading coefficient, negative 5, is negative. Can't be negative. Second problem is I've got a fraction. Now, I don't know about you, but I have a philosophy of work smarter, not harder. So, that means if I can save myself extra work, if I can do something that could possibly take 2 steps in 1 step, I'm going to do it because it's going to save me time, it's going to save space, it's going to save all kinds of stuff. So let's try to take care of both of these problems in 1 step. So let's think about it. In order to get the 5 to become a negative, or a positive, excuse me, I would need to multiply it by what? Negative 1. And in order to get the fraction, 1/2, to become a whole number, what would I multiply that by? 2. Positive 2 and negative 1. Well, guess what I can do? I can combine those. What's negative 1 times 2? Negative 2. So I can multiply every single term in this equation by negative 2 and take care of both problems at one time. Because do you see what we did? This needed to be multiplied by 2 to make it a whole number. And the 5 needs to be multiplied by negative 1. So if I change it to negative 2, it takes care of all the problems. So negative 2 times negative 5x is 10x. Negative 1/2 times negative 2 is positive 1y. Negative 2 times negative 11 is 22. You would get the same answer if you did it in 2 different steps. Like if you said, okay, I'm going to take care of the negative problem first, so I'm going to multiply everything by negative 1. You did all that, and then you say, okay, now I've got to take care of my fraction, so I multiply everything by 2. If you did it in 2 different steps, it would take a little longer, but you would still get the same answer. So it's not wrong if you do it in 2 different steps. I was just trying to save you a little bit of time and do it all in 1 step. Okay? So then we're going to go a step further, of course. We're not going to give you exactly what we need. We're going to give you 2 other parts, and this is where yesterday's lesson comes into play. It's actually very simple. It's just you're going to have to start off using another form. Yesterday, what form did we learn?
Slope-intercept form. Wait, no,
Point-slope. Point-slope form. Look what they've given me here. A point and a slope. So I can use that to plug it into that equation to then rewrite it to standard form. You say, well, okay, why can't I just go ahead and write it in standard form? Because the way standard form is set up, it does not have a spot for your x-intercept, y-intercept, a point, or a slope. It's written ax plus by equals c. So we can't ever plug actual information into that. Standard form is just taking an existing equation and putting it in a certain order. So we have to come up with an equation so we can even get it into standard form. We're going to use point-slope form because that's what they gave us, a point and a slope. It's the easiest one to use. So who can tell me what is point-slope form? Stephanie?
Y minus y1 equals m times x minus x1.
Very good. So let's plug in the information we know. We know negative 4 is x1. We know 3 is y1. So we say y minus 3 equals m, which is negative 2, times x minus x1. So that's going to mean plus 4. Now, I remember yesterday when I was teaching this, a couple people said, so wait, we would never do distributive property? You never want us to solve it? Here it is. This is where you get to do distributive property, because now I have an equation, and now I need to reorder the term so it's in standard form. So I want to do distributive property. Y minus 3 equals negative 2x minus 8. And now I just combine like terms and put it in standard form. So I'm going to add 2x to both sides, because I know the x and y need to be together. So I have 2x plus 1y minus 3 equals negative 8. Then what would I do? Add 3 to both sides. 2x plus 1y equals negative 5. Is this equation now in standard form?
Yes.
Yep. I don't have a negative leading coefficient, and I don't have a fraction. That's my answer. All right, last example that we're going to do the exact same thing. Point slope form, because I don't have an equation to even put in standard form. So I need to come up with an equation. Since they gave me a point and a slope, that's the easiest one to do. So Bomnet, plug in the numbers for me.
Okay. Y plus 7
Very good.
equals 1/4 times x plus 4.
What's the formula? X minus x1. So x minus 4, because 4 is not already a negative. That's when we would change it. Okay, so what would I do now? Madison?
You would do distributive property?
Yep, let's go ahead and do distributive property. Y plus 7 equals 1/4 x.
Minus 1.
Very good, because remember what we learned about multiplying a fraction by the same number as the denominator? It's always going to be the numerator, so minus 1. So now combine like terms. What am I going to do?
Move the 1/4 x to the other side.
Okay, we can move the 1/4 x to the other side, so negative 1/4 x. And I have negative 1/4 x plus 1y plus 7 equals negative 1. Then what would I do?
Subtract 7.
Subtract 7. Negative 1/4 x plus 1y equals negative 8. Is this an okay standard form? No. How many problems do I have?
Well, it's a negative. The first number is negative, and it's a fraction.
Very good. So I got 2 problems. I got the 2 things that they tell me I cannot have. I have a negative and a fraction. So what number can I multiply this fraction by to make it a whole number? Madison?
Negative 4.
You can multiply by 4, and since it's a negative, I can multiply it by a negative 4, and it's going to change it to a positive. So I take care of both of my problems in one step. Negative 4 times 1/4 is 1x minus 4y equals 32. So now I have my final answer, and it is in standard form. This is your homework tonight, page 311, numbers 4 through 15 all.